2022 BSc Main Physics, Semester 5, paper the electronics question paper. Electronics question paper solved December 2022 University question paper. Not solved here, only a question is given, and if anyone needs to get the answer, they can ask in the comment box. I will give the question paper here, and if anyone requires its answer, ask through the comment box. These are the questions. I shall read. 5th semester BSc degree examination, December 2022, marks maximum 80, time 3 hours. Paper 5, electronics. Semester 5, BSc main physics. Section A. Section A, state Newton's theorem. Question number 1. 1 mark question. All the 10 questions are compulsory. We have to answer the question in 1 or 2 sentences. These are the questions. All 10 questions in this section, in this part A, are compulsory. Number 1, state Newton's theorem. Number 2, what do you mean by diffusion layer? Number 3, what do you mean by peak inverse voltage? 4, define current amplification factor alpha, that is for a transistor. What do you mean by quiescent point, Q point? These are all simple direct questions. Question number 6. Question number 6, what is meant by multi-stage amplifier? Multi-stage amplifier is actually not in your syllabus, but there's a question. Here is the question, multi-stage amplifier. Number 7, explain Bergson criterion for oscillation. 8, define the modulation. 8, what is an operation amplifier? 10, what are the difference between BJT and FET, field effective transistor? 10 into 1, 10 marks. Question number section B, answer any 8 questions not exceeding a paragraph, and the question carries, each question carries 2 marks. Number 11, explain the maximum power transfer theorem. Question number 12, what is load line in transistor? What is its significance? Number 13, how Zener diode maintains constant voltage across the load. Next question, number 14, explain how transistor works as an amplifier. What is question number 15? What is stability factor? Stability factor of fixed bias transistor. Explain the significance of stability factor. Number 16, show that gamma is 1 by 1 minus alpha. Number 17, explain the circuit operation of a push-pull amplifier. Number 18, what are the advantages of negative feedback amplifier? Number 19, why modulation is necessary in communication? Number 20, 20th question, what are the advantages and disadvantages of frequency modulation? Describe the working of a MOSFET. Number 22, discuss the operation of a summing amplifier, that is from op-amp. Number 23, what is the role of coupling capacitors in an amplifier circuit? Number 24, why dual power supply is used in op-amp? Number 26, what is the difference between open loop gain AV and closed loop gain AVF? Number 28, draw the frequency spectrum of FM wave. 8 into 2, 16 marks. Now part C, which is a problem part, problem side, questions from problem part. Answer any 6 questions. Each question carries 4 marks. Number 27. A crystal diode having internal resistance Ri is equal to 20 ohm is used for half. Internal resistance RF 20 ohm is used for half wave rectification if the load voltage V is equal to sine omega t. Sine omega t, that is BM is 1. Our load resistance R is 800 ohm. Find IM, IDC, IRMS, B, SC power input and DC power output, C, DC output power. Next, question number 28. A half-wave rectifier uses two diodes of internal resistance of each may be assumed to be 20 ohm. The transformer RMS voltage from center tap to each secondary is 50 volt. And load resistance 980 ohm. Find main load current, the RMS value of load current. This is half-wave rectification. So we have to use the equations of half-wave rectification. You need not to bother about center tap transformer. You take the voltage only, input voltage. Next question, a German transistor is to be operated at a zero signal. IC is 1 mA. If the collector supply VCC is 12 volt, what's the value of RB in the base resistor method? Given beta is 100. Base resistor method of biasing. Number 30. Question number 30. The overall gain of a multi-stage amplifier is 140. When negative feedback is applied, the gain is reduced to 17.5. Find the fraction of the output that is fed back to the input. When negative feedback amplifier, AF is equal to A by 1 plus AM enനുള്ള equation. Number 31. In a phase shift oscillator, R1 is equal to R2 is equal to R3 is equal to 1 mega ohm. C1 is equal to C2 is equal to C3 is 60 PF. At what frequency does the circuit resonate? F is 1 by 2 pi RC root 6 എന്നുള്ള equation. F is 1 by 2 pi RC root 6. ആ equation apply ആണ്. Number 32. The maximum peak-to-peak voltage of AM wave is 16 millivolt and the minimum peak-to-peak voltage is 4 millivolt. Calculate the modulation factor. Number 32. Number 33. A carrier wave of 500 units is subjected to 100% amplitude modulation. Determine the power in sidebands and power of modulated wave. Number 34. A FET has a drain current of 5 milliampere. If IDSS is 10 milliampere and VGS off is minus 6 volt, find the gate source voltage and the pinch of voltage. Pinch of voltage, BP. Next question. Calculate the output voltage from the non-inverting amplifier circuit in the following figures for an input of 120 microvolt. That is an op-amp amplifier. We have to find the output. Number 36. If beta of a transistor circuit in the figure is 50, find the value of IC using using both alpha and beta. You have to use alpha and beta to calculate ice. Data is given in the figure. Next question, number 37. The first stage voltage gain of a two-stage amplifier is 100 and its second voltage is 160. Find the load gain dB. You multiply the gains and convert it into decibel. Number 38. An amplifier has a voltage gain of 50. To reduce the distortion present in it, 10% negative feedback is applied to calculate the voltage gain. Calculate voltage gain with the feedback. 6 into 4 equal to 24 marks. Part D, essay type questions. We have to answer two questions. Answer any two questions. Each question carries 15 marks. Number 39. Explain with the circuit diagram the action of a full wave rectifier using center tap transformer. Derive an expression for rectification efficiency and ripple factor. Next question, number 40. What are filter circuits? Explain the working of a capacitor filter and inductor filter. Question number 41. What is the need for transistor biasing? Discuss the potential divider bias method of transistor biasing. Number 42. Discuss the characteristics of CBC transistor configurations and with the neat diagrams. Number 40. With the circuit diagram, explain the working of Hartley and Colpitts oscillators. Number 44. With the necessary diagram, explain the op-amp working as an inverting and non-inverting amplifier. Here, 2 into 15, 30 marks. These are the questions. And if you have any doubt in any of the questions, ask through the comment box. If you put a question in the comment box, you will get the answer as my reply. That is all. Thank you very much.